Um, Chapter 4, absolute value. So we have to remember that the graph of the absolute value, the standard looks like this. That's what we refer to. Um, so absolute value of x is -1, and you take the absolute value of -1, you get 1. That's why when you have x equals -1, y would equal 1 as well. If you put a -2, it will give you +2 for the y value. But the x value doesn't change the sign. So the absolute value of +1 is 1, the absolute value of +2 is 2. So that's how it goes. So if I'm graphing something like this right here, I need to find my pivot point, you know, this where the V is formed right here. And that point is here, you take it from this two values right here. So pivot point will be, you have to change the sign of this, so it'll be 1 and 3. This is an important point to me, so it's 1 and 3 right there. Okay, now what I advise you to do, since you have your pivot point right there at 1 and 3, take a couple of values just next to the x value right here, a couple of x values. So I'll go maybe 2 and 3. Sub into here, 2 minus 1 is 1. Absolute value of 1 is 1 times -2 gives you -2 plus 3 gives you 1. So there's that. Sub in 3 right here. 3 minus 1 is 2. The absolute value of 2 is 2. 2 times -2 here is -4 plus 3 is -1. All you need to do now, just come and plot these 2 points, 2 and 1 right here, and 3 and -1, which is right there. Now, this here gives you an axis of symmetry. That the pivot point give you an axis of symmetry, because the V-shape or the absolute value graph is symmetrical. So this is a symmetry of this line right here. So therefore, since you know there's a symmetry at the pivot point, so you take this point, it's 1 away from the axis of symmetry, so go just 1 away on this side, and you'll have your other point. This is 1, 2 away from the axis of symmetry, so go to on the other side, 2 away, and plot your point. Now you could just graph this nice and simple. So this is how this graph looks like. So this is a graphing a piecewise function. So you have two graphs that you have to graph with a limited domain. So the x minus 1, the pivot point, so you look at this as y equals x minus 1, where x is greater than or equal to -1. So the pivot point right here is at 1 and 0, because you change the sign of this, and that, since there's nothing there, that's a 0. So we have a pivot point at 1 and 0, so right there. Now, what I'm gonna do, I'm gonna xy, write the 1 and 0, and I'm gonna go the next value to x, either 2 or 0, so I'm gonna go low, -1. This is the last x value that you could have in the negative direction, because it has to be x has to be greater than or equal to -1. So if we sub in 0 in here, I get -1. The absolute value of -1 is +1. If I sub in -1 here, I get -2, and the absolute value of -2 is +2. So I'm going to plot this point 0 and 1, and then -1 and 2 right there. This is the axis of symmetry for this. So I'm going to reflect this point. I'm going to get another point right here. I'm going to get another. That's 1, 2. So I go 1, 2, and I get my other point right there. Now I'm just going to plot this. This continues, but this here stops right there because of the domain restriction right there. And then I'm going to go to the other one. Y equals 3 absolute value of x plus 2 minus 1. The pivot point here is -2 and -1. -2 and -1 right there. And then I'm just going to do table of values. Gonna XY. I'm going to put in -2 and -1. I'm going to, so see, the thing is, this point we have to reject. So I'm going to start at -1. Just give me 1 second there. Oh, X is, that works within the domain. So X has to be less than -1. So what I'm going to do, I'm going to go to -3. -3, if I sub it in, it gives me -1. The absolute value of -1 is 1 times 3 is 3 minus 1 is 2. Also, I'm going to sub in this -1 right here. So if I sub in -1 there, I get 1 times absolute value of 1 is 1 times 3 is 3 minus 1 is 2. So what I have -1 and 2 supposed to be an open circle because it's not included, but since that point is shared with the other graph, is still filled in. Then we have -3 and -2, -3 and 2, which is right there. We know this is the axis of symmetry right here for this graph. So I could do another point like -4. -4, I put it there. That's -2. Absolute value is +2 times 3 is 6 minus 1 is 5. So let me just make sure. Yeah, 2, 6, 5. So now -4 and 5. 1, 2, 3, 4, 5, and -4 right there. Now I could reflect that into the axis symmetry, but you know, we cannot. My domain restriction there, X has to be less than -1, so I cannot go below this point. So therefore, if I'm graphing the rest of this, I'm gonna do this, and then here it's continuous on this side. So you could just do that there. So it continues right here, and it continues right there. Now, I could organize this table for you a little bit, maybe just to XY. As we agreed, -2 and -1 was the pivot point, but -1 and 2, that's where the domain stops. Cannot go on the right side of -1, so you cannot have 0 or 1 or anything like that. And then -3 and -4, that gave me -3, gave me 2, -4 gave me 5. And I plotted all these points, and that's the kind of graph we've gotten. And this is called the piecewise function. Till next time, stay safe. Thanks for watching.